Let me explain the regulator of UNILOK. A pressure regulator fundamentally functions to control the pressure of a fluid in a stable and consistent control. It also performs to maintain a consistent flow from the set downstream pressure that is set up in response to changes in system pressure. In other words, it's a device that reduces high pressure to a lower pressure, suitable for the user system. A regulator is composed of three elements: the control element, the sensing element, and the loading element. The control element consists of the seat retainer, seat, poppet spring, and poppet guide. The sensing element is made up of the diaphragm. The loading element consists of the stem plate, load spring, and pusher. Next, let us present the operating principle of the regulator. High-pressure fluid enters the high-pressure chamber on the inlet side of the regulator. The high pressure is indicated by the inlet pressure gauge, and the pressure is maintained. When the handle is turned clockwise, the load spring is compressed, pushing the diaphragm downwards, and the poppet moves down, allowing the fluid to flow to the outlet side. The fluid that flows to the outlet side then enters the low-pressure chamber, pushing the diaphragm in the opposite direction. When the force of the load spring and the pressure balance, the outlet pressure stabilizes. The outlet pressure gauge indicates the pressure in the low-pressure chamber. Turning the handle counterclockwise reduces the force of the load spring and the pressure in the low-pressure chamber, which is called the outlet pressure. Next, I will explain the droop test. First, droop indicates the degree of change in outlet pressure according to the flow rate. In the droop test, with the inlet pressure held constant, the outlet pressure is set, and the test then measures the change in outlet pressure as the flow rate increases. When the flow rate is 60 SLPM, the outlet pressure is 34, and at 120 SLPM, it is 30. As the flow rate increases, droop also increases. I will now explain the flow curve, which shows the change in pressure with the increase in flow rate. In the graph, the x-axis represents flow rate, and the y-axis represents outlet pressure. When the flow rate is 100 SLPM, the outlet pressure is 96 psig, and at 500 SLPM, the outlet pressure is 89 psig. From the flow curve graph, the increase in flow rate allows you to observe the pressure droop, enabling the selection of a regulator that is suitable for your system's pressure. Lastly, I will explain the two types of UNILOK regulators. UNILOK regulators have two types, which are non-tied and tied regulators. First, the non-tied type has the poppet and diaphragm separated. Unlike the tied type, the non-tied type does not pull the poppet upwards when the diaphragm rises. Also, if some particles or substances flow inside the regulator and the outlet pressure rises, you must close the regulator or the downstream valve. Next, the tied type regulator has an integrated structure where the poppet and diaphragm are connected. When some particles cause the outlet pressure to rise, the poppet also rises, preventing excessive increase in the outlet pressure. A significant advantage of the tied regulator is its ability to prevent damage to the system on the outlet side, caused by rising outlet pressure in the event of internal leakage. This is the end of the UNILOK regulator explanation. Thank you.